Yes, welcome to our discussion. So today we are going to look at a concept in polynomials, and basically this is a topic that we're going to see which is going to be applied, have a wide range of applications, or rather in mathematics and sciences. And we're going to appreciate after our discussion, or rather from our introduction, that this has some specific applications which of course are very relevant to our day-to-day life. Now in this case we're going to look at just a general definition for the term polynomial, and try to see what are some of these specific terms that we are going to have in this concept of polynomials. Now basically we're going to refer to a polynomial as a single term or finite sum of terms, and in this case whenever I'm talking about the concept of a term, so therefore this is a single term or a finite sum of terms. Now if we try to look at this general definition for the concept of polynomials, we're seeing that there are some specific terms as well which have been used in this specific or rather general definition for this, whereby I'm going to elaborate on the concept of what is referred to as a term, and then next we're going to see this finite means there's a particular or a restricted range of these specific terms. And if we use the term infinite, which means it continuously goes on without having an end. So in this case, we're going to see that from this definition, if I may write an expression over 2x plus 3y, this is just an arbitrary expression that I'm going to use to try to find out how we can be able to understand the concept of a term. So my expression, which is given as 2x plus y, has got what we call two terms. And in an essence, a term I refer to this part of an expression which has been given as 2x, and there's another one which has been given as x. Now in this case, when we talk about the sum, then therefore it's going to refer to as either a single term or a sum of finite terms. So in this case, we can see that there are two terms in this particular case, as I've mentioned. So therefore, a term refers to this particular single entity of an expression which is being added to another one to give a specific meaning. Maybe it's some sort of variables that we're going to see. So that generally is a definition of what we refer to as a polynomial. And we have different ranges of polynomials now that I've mentioned the concept of terms. We're going to see that we can be able to have what we call monomials, which are of course a part of what we are describing, and then we have what we call binomials, and then lastly we are going to have polynomials. Now from these specific terms, we can see that there's a characteristic ending for the services, which are the ending part of these specific names. So for 1, 2, and 3, then therefore we are going to see that also the prefixes which have been used for mono, bi implying 2, poly implying more than 2. Therefore, it implies that this is made up of a single term, whereas this is made up of two terms, and this is of course more than 2. So therefore, if we try to look at the expression that I have just written on the board, we can be able to conclude that it's made up of two terms. So if I were to give an expression like 2x squared, this will be referred to as a monomial because it has a single term. And then next, if I write an expression for 2x squared plus 3, this is going to be given as a binomial because it has got two terms. And in case I write maybe 2x squared plus y plus 7, then this is going to be referred to as a polynomial because it consists of 3 terms. So if I try to go ahead and try to look at a general expression for this concept of a polynomial, I'm going to give describe what we call a polynomial in a particular number. So in this case, we are just going to use an arbitrary number, of course the x and or y, which we are used to in most of the time. So we're going to use a polynomial in a number x and try to see how we can be able to describe that one. So if we're given that particular case in order to describe, then we're going to see that if we have a number n, which is of course if n is a non-negative integer, and the numbers a0, a1, a2 to a particular range. We said we have a finite number, so to an, then we're going to see that this range of numbers are going to be, then where we can say these real numbers. We're going to see that a polynomial is in x can be described using these specific terms and conditions that we have given here. Then a polynomial in x can be described as, so we're going to give this range of numbers. As we said, a polynomial is a sum of finite terms. So therefore, these are specific terms which have been given for this set of numbers, and then we have said it's been given n times, where n is a non-negative integer. We can be able to represent a polynomial in x using this specific term, which is going to be described as a polynomial in x, which is a sum of these finite terms, whereby we have a0, and this is going to be x n plus a1 x n minus 1 plus a2 n minus 2, and then this is going to go on until we reach a point whereby this is a, okay, there's a factor of x here in this particular term, so this is a x minus 3, rather just because of space I'm going to eliminate that. So it's going to add up until a point whereby we have a n, but of course the factor of x at this specific point will be n minus n, therefore which implies unity. Therefore we're going to just eliminate this one. It's just for the sake of simplicity. So therefore this is just the general expression that we are going to use to represent a polynomial in x, which is going to be, of course, a general representations for this polynomial in x. Now whenever we are representing a polynomial using the expression or the equation that I've given, which is a general equation, that lower part of the board, we're going to see that there are different terms that we can use to describe these coefficients at this specific point, for the first and the last ones respectively. So therefore we're going to have the first one referred to as a leading coefficient, and the last one is going to be referred to as a constant term. So from the general representation of a polynomial in x, we're going to have a leading coefficient and the constant term. Perhaps those are going to assist us in trying to describe some of the concepts that we're going to come across in polynomials. So lastly, we are going to look at what we call a degree of polynomials. So in case maybe I represent a number as 2x cubed plus 2x squared plus x plus 7. So if you try to look at that particular expression, whereby the concept of a degree of a polynomial is going to refer to the highest power, degree of polynomial is going to refer to the highest power in the polynomials, of course, terms. So in this case, if you try to look at the specific examples I've given, you can can be able to see that x has been raised to power 3. So now we're going to, of course, ignore the coefficients in this particular case and consider the x, or the exponent, which is appearing in this polynomial. Therefore, we have x raised to power 3, x raised to power 2, x1, and perhaps this one is not shown. This is going to be a constant. So therefore, we're going to see that the highest power in this particular case is going to be x to power 3. So therefore, we're going to take this particular power, which is 3, and this is going to be the degree of this specific polynomial. So we're going to see other ranges of polynomials that we have described for binomials, and basically look at different ways in which we're going to treat them, especially when it comes to operations. And this basically is going to open for us, of course, a window for discussing other concepts which are going to be related to the concept of polynomials. But lastly, before we leave, I'd like us to appreciate some of the applications which we are going to mention in some of our videos concerning polynomials. So in a quick way, we're going to look at some of the ways in which we can be able to appreciate this concept of polynomial. So polynomials have a wide range of application, especially in the construction industry, and some of us are aware of the roller coaster. So therefore, in order to find what we refer to as in order to describe the curves of a roller coaster, we're going to apply the concept of polynomials. And basically from this, generally they are very widely applicable in the construction industry. And then we're going to see that in mathematical models that are used in meteorology, are going to employ the concept of polynomials in order to describe the weather patterns. And then lastly, we can be able to give just a last part of these patterns. So last but not least, we're going to give this one especially is going to be applicable in marketing and finance. Marketing, finance, and even in some instances in describing or maybe trying to make some applications in our stock market. So therefore, these are some of the applications that we're going to find polynomials being applied. And as we go by, we will also have other additional examples that we're going to use. So I hope we'll stop there. Catch us in our next video as we're going to look at some of the operations that we can be able to do with polynomials. So that is it for today, guys. Bye. God bless you.